Will the universe ever stop expanding? Imagine stepping outside on a clear night and gazing up at the stars. It feels peaceful, doesn't it? The stars sparkle gently, the planets make their slow journeys across the sky, and everything seems still. But that calm, twinkling canvas is lying to you. Beneath that serene surface, the universe is stretching, growing, and expanding at a rate so wild that even scientists are left scratching their heads. The big question is, will it ever stop? To get to the bottom of this cosmic mystery, we need to talk about what's really going on out there. When scientists say the universe is expanding, they mean it in the most literal sense. Galaxies, the colossal collections of stars, planets, and gas, are moving farther apart. But it's not that the galaxies themselves are moving. Instead, the space between them is growing. Think of the universe like a giant loaf of bread rising in the oven. The galaxies are like raisins embedded in the dough. As the bread expands, the raisins get farther away from one another. This isn't just some quirky analogy, it's exactly how scientists like Dan Skolnick, a physics professor at Duke University, describe what's happening. How did we get here? The Big Bang and beyond. Let's rewind the clock about 13.8 billion years. Everything we know, every atom, every particle, every speck of energy was squished into a single, then unimaginably dense and hot point. Then, boom, the Big Bang happened. The universe began expanding, space itself unfurling like a massive cosmic balloon. From that moment, galaxies started to spread out as the universe grew. For a long time, scientists thought the expansion would slow down over time. Why? Because gravity, nature's great pull, acts as a brake. Just like how a ball tossed into the air eventually slows down and falls back, the thinking was that gravity would slow the universe's expansion. And it did, for a while. But then something shocking happened. In the late 1990s, astronomers discovered that the universe wasn't just expanding, it was accelerating. Imagine tossing that ball into the air and watching it suddenly shoot upward at lightning speed instead of falling back. It didn't make sense. What was causing this mysterious speed up? Scientists needed an explanation, and they came up with a name for the culprit: dark energy. The mystery of dark energy. Dark energy sounds like something out of a sci-fi movie, but it's very real and incredibly confusing. Scientists know it's there because of its effects, but they don't know what it actually is. Here's what they do know. Dark energy is some kind of force that lives in the vast, empty spaces of the universe, and it doesn't pull things together like gravity does. Instead, it pushes things apart. Skolnick describes dark energy as a repulsive force. The more space there is, the stronger its pushing power becomes. It's like an invisible hand stretching the universe faster and faster. Right now, dark energy makes up about 70% of the universe. To put it simply, dark energy is the boss when it comes to the fate of the cosmos. But there's a catch. Because scientists don't fully understand what dark energy is or how it works, predicting the universe's future is like trying to solve a puzzle with half the pieces missing. Measuring the universe's growth. To figure out just how fast the universe is expanding, scientists use a number called the Hubble constant. This number tells us how quickly galaxies are moving away from us. To measure it, researchers look at supernovae, stars that explode in dazzling flashes of light, and pulsating stars in far-off galaxies. These cosmic markers act like mileposts, helping scientists measure distances and speeds. In the 1990s, Wendy Friedman, an expert in astronomy, led a groundbreaking project to calculate the Hubble constant with incredible precision. But here's where things get messy. In recent years, scientists have found that different methods of calculating the Hubble constant don't agree. Some measurements suggest one rate of expansion, while others suggest a different rate. This disagreement is called the Hubble tension, and it's driving scientists bananas. Friedman says the tension might mean there's something wrong with the way we're collecting data, or it could mean the universe is trying to tell us something new about how it works. If it's the latter, we might need to rethink everything we know about the cosmos. As Friedman puts it, it's suggesting there's physics that we don't know about. And if we don't understand the physics of the universe, how can we predict its fate? What are the endgame scenarios? Let's fast forward billions or even trillions of years into the future. What will happen to the universe if it keeps expanding? Scientists have come up with several possibilities, and each one is a mix of fascinating and terrifying. Scenario 1, the Big Freeze. If dark energy continues doing what it's doing now, pushing galaxies apart at an accelerating rate, we're in for a cold, lonely future. This is called the Big Freeze. Over time, galaxies will drift so far apart that they won't even be visible to one another. Stars will burn out one by one and no new stars will form. Eventually, space will become a dark, frigid void. It's like the universe is slowly falling asleep, never to wake up again. Scenario 2, the Big Rip now. Imagine dark energy's pushing power gets even stronger as time goes on. In this scenario, the universe's expansion doesn't just accelerate, it goes into overdrive. Galaxies won't just drift apart, they'll be ripped away from each other. Then, the ripping will spread to stars, planets, and eventually atoms themselves. This catastrophic ending is called the Big Rip. As Skolnick says, it's like asking, do you want the universe to end with a whisper or with violence? Scenario 3, the Big Crunch. Not everyone agrees that the universe will expand forever. Paul Steinhardt, a theoretical physicist, has a different idea. He thinks dark energy might weaken over time. If that happens, the universe's expansion could slow down, stop, and then reverse. Galaxies would start rushing toward one another, eventually collapsing into a single, dense point, kind of like pressing rewind on the Big Bang. This dramatic finale is known as the Big Crunch, and here's the twist. In some versions of this theory, the universe could bounce back and start expanding again, creating a cyclical universe that repeats itself forever. The search for answers. With all these possibilities, you might be wondering, which one is right? The truth is, no one knows for sure. As Friedman says, we've lost that predictability. But scientists aren't giving up. They're building powerful tools like the James Webb Space Telescope to peer deeper into the universe than ever before. By studying ancient light from the earliest days of the cosmos, they hope to uncover clues about dark energy and the universe's ultimate fate. Science takes time, sometimes decades, sometimes centuries, but every question brings us closer to understanding the universe we call home. Whether the cosmos ends in a freeze, a rip, or a crunch, one thing is certain: the universe's story is far from over. And as long as we keep asking questions, we'll keep uncovering the secrets of the stars.